Newton's laws of motion. For those of you who haven't heard his laws, I'll quickly zoom through them and explain them to you as clear as possible. His first law. Every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. By this, Newton meant that if an object lays at rest and doesn't move, it won't move until an external force acts upon it. If an object is in motion, it will stay in motion until other forces are impressed onto the object to either slow it down or change its trail of movement. This is another way of defining inertia. Newton's second law. Force is equal to change in momentum per change in time. For a constant mass, force equals mass times acceleration. This meant that a force on an object is dependent on its mass and at the acceleration that it is traveling. For example, if the object doesn't move, its acceleration is 0. The force would be acceleration times its mass, which would make the force equal 0. Now, if the object is moving, and you know at what acceleration it is moving, then by multiplying that number with its mass, you can find the force that applies through its trail of motion. Newton's third law of motion. For every action, there is an equal and opposite reaction. This final law implies that if you act upon an object in any sort of physical way, it will exert the same amount of force back at you. Example of this is if you blow a balloon and let it go, it will fly around the room. The action would be the force of the air being thrown at the balloon, and the reaction would be the balloon moving in the opposite direction of this action. You can imagine this scenario. You can try it for yourself. Types of propulsion systems. Before talking about how rockets work, you must know that different types of engines equal to different ways of rockets work. And also, I will need to discuss the two primary engines involved in rockets: solid fuel rocket engines and liquid fuel rocket engines. Quick definitions. You can read these definitions. You can pause the video and read them. I'll just go to the next slide right now. Liquid fuel engine system. Liquid rocket engines use a liquid oxidizer and a liquid fuel. These propellants are usually pumped up, then mixed together and burned in the engine's combustion chamber. If you think of this in a car, it is pretty much exactly the same. You have the fuel, the combustion chamber, where ignition takes place, and it all comes out from the exhaust. Whereas in a rocket, it just comes out of a nozzle. There are many fuels and oxidizers that can be used. Oxygen, for obvious reasons, is the most common used oxidizer. Some of the fuels used are hydrogen, kerosene, and hydrazine. Using liquid propellant allows a greater mass to be carried than if a gas were used. Liquid rockets also can be throttled, which is a big plus for them. This means that the power level of operation can be changed. Solid rocket motors cannot be throttled. Solid fuel engine system. Solid rockets burn a solid that is made up of the fuel and oxidizer. This rubbery or plastic-like solid is called the grain. The solid is packed into a cylindrical casing with a passage through the middle. The solid fuel and the oxidizer are united by an electrical charge. Solid rockets don't require pumps, so they're less complex than liquid rockets. However, once the solid is ignited, there's no turning back. Solid rockets cannot easily be stopped, and usually stop only when the fuel is depleted. Solid rockets are used for missiles and as boosters for launch vehicles. They're also used in fireworks. Probably the most famous solid rockets are those used for space shuttles.